Hello, everyone.
Hello, Dan.
Hey, Dan.
Hey, how's it going? So today, um, depending on who joins, it might be a short one. It might be a short one today. I'm still kind of waiting for more topics to be proposed and come in on the from other vendors grappling with some of the core issues and make sure that we're using this as a clearinghouse for those issues. Um, but those um, those questions aren't really rolling in. Um, from our side, from what we're doing on the Intel side, I'll I'll talk about what we're doing now that we've kind of gotten the green light from Bjorn to start deploying some things. I'll talk about what we're doing, but we're kind of in a developing the patches phase. So um, not too much to show today, but I'll talk about where we're going and so people can get an idea of that. And then hopefully we can get other vendors, particularly risk people, um, AMD people, ARM people in to this call. This was mainly set up. Well, one of the reasons for this call was one of the main developers for another vendor was in the Australia time zones. That's why we have this meeting, and also for our Intel folks that are in China. This is also for this time slot. But this might be it for quorum today. Let me just go ahead and share what I got, and we'll go through it. And if we end up not needing the full time, we can end early. Okay, is that coming through? I think it is. So just a typical reminder, open source call. I think everybody I've seen join today has seen this before, so don't need to repeat it. This is place to supplement list discussions and anything. Well, and it's recorded, so people can review it from the mailing list if they need to. But we did have one question come in from the list, and I want to make sure I answered it, and also give other people a chance to weigh in on it in case they don't like my answer. But Peter, I see you joined. Um, did I capture the concern correctly? You're worried about how does the guest know that whatever in-memory validation has been done by the kind of the host side, the connect side of the equation, how does the guest know that nobody's tampered with um, that measurements, those measurements before the guest can consume them?
Yeah, I think that's the majority of my concern. Thanks, Dan.
Yeah, yeah, and so I think what I mean. So this is also kind of leading into what I want to build next, is so that we can start pointing people to test code that's common, and we don't actually need an endpoint device to show the flow and how this all works. But um, my expectation is that all of that stuff is signed, so that the SPDM session is established with device and host side and TSM certificates, uh, and then basically anything that goes over that session is signed. And so if anybody tampered with that, you would see it because that session is protected. And then from that session, we establish IDE, and then IDE really is link encryption and integrity protection. So that if anybody is malicious in the man in the middle on the link at that point, um, that stuff is also all integrity and protected as well. and the crux of that protection is that if somebody does tamper with it, the hardware will notice, um, and it will tear down the IDE connection, or IDE will go into an error state. So by the time we get to the guest side and we're trying to validate the provenance of a TDI, that's like a that could be either the entire device pass through or some subset of it, and like a VF subset of it. That the TSM, like the that the device, the interface report we get from the device will be relative to the current status of IDE, um, and also signed. And so you know that either either IDE is still up and you can trust the report, or you get the report and you trust the device and somebody attacks it and IDE goes down. So then you're dependent on the hardware to make sure that after you check it, nothing has happened. And so to me, all of that concern is kind of encompassed by what IDE, the role of IDE and IDE error states is offering for this protection. And if anybody has concerns or questions about what I just said, that's kind of my interpretation of why I think it's okay.
Sure, it's not a question, but just adding on top of it, we also have nonce on SPDM for freshness guarantee. So if someone is trying to replace the entire report with an old one, the relaying party can detect using a nonce.
That's an important point too. Yeah, even if everything checks out, that the transcript, the nonce for the SPDM session, the nonce for the report generation.
Correct.
Is there any? Is that the only two nonces that are really?
So nonce, yes, nonce is going to come from the relaying party and goes along with the get measurement request, right? That it's going to be added to the response. So it's a single nonce we're talking about.
Yeah. Okay. Yeah. But it's the same nonce basically the same nonce we use for the session establishment.
And it's the nonce that you send with get measurements, not doing the session establishment. Yeah. So nonce ideally is expected to be generated by the relaying party and sent down to the guest, and guest will request for a new measurement using this nonce.
Yep.
Yeah. So we're expecting measurements to be fetched at runtime and not reuse the one that's fetched using the session establishment.
Right. Yes. Yeah, I was going to say that we have the get measurement nonce. There's also a nonce that can be provided at session establishment time. But yeah, but I'm saying like we have multiple chances for people to check the freshness of different aspects of the link. But you're right, that last level, can I trust this device? The current measurements, I can as a relying party, I can supply the nonce to make sure that these are fresh measurements with a fresh nonce.
Yeah. And there's one more aspect that we didn't talk about in the past, Dan. How do we chain all the reports coming from these devices to the tenant from the relaying party point of view, right? So I'm a relaying party getting all these reports, getting like a number of reports from n devices attached to the tenant. I'm also getting the TVM measurements. How do I chain all these things together?
I am assuming, and this is the part where we want to get into actual instead of theoretical, actually putting pen to paper on the code so we can point to this. But and I think this is also part of Peter's question was, when do these things get actually measured into like RTMRs or PCRs on the system?
These TDA measurements do not go into RTMRs.
How do you plan to bind the device measurements to the guest without adding them to the platform?
Yeah, I think that's something we have to figure out. Because there are multiple ways to do that. One, you can put the entire measurement to the RTMR, but you run out of space, right? The other option is you can put the certificate hash, the device certificate chain hash of that into the RTMR. That's another option. Or maybe just have a cookie that's generated at boot time and have that cookie logged into the RTMR and use that to chain. There are multiple ways to do this. Yeah.
Yeah, I mean, as my expectation that we would at some point in this flow, as we're doing all these validations, and that we're basically hashing the state of the like a take a of the PCI topology of the devices we've accepted, and hashing that into the chain at some point.
Yeah.
Gobi, what was your negative on your first solution? I didn't quite hear. Sorry.
You mean the first one? Sorry, I give 3 options. Right, one, you can take the entire report, hash the entire report, and put the hash into an RTMR, so you can keep extending it. Right, so every time you go fetch a measurement, you're going to keep extending that hash. That's one option. The second option is to fetch the device certificate chain, hash it, and put that hash into the RTMR. So you have to do this just once. The third option is where you can have the device generate a boot cookie or TVM cookie and have that cookie logged into one of these slots that you can use for chaining from the laying party side.
Understood. Okay.
Yeah, the question is who's going to do all this, right? So would it be the TSM that does it, or should it be the guest, the kernel that needs to do this?
I mean, I'm hoping that we can push, like that we would give the mechanisms for somebody else to basically for user space to pick that policy of what they want to hash or not hash when. I think the thing you were saying at the beginning that Peter was asking about was pushing the entire measurement retrieval blob into the as a document into the RTMR is probably too big, so we would want to do a hash.
Yeah.
Well, yeah. Oh, agreed. I'm assuming I didn't understand the too big since I assumed everything going into RTMRs was hashed. So thanks.
Yeah. So I mean, so yes, yeah. This is where we start getting into the details and wanting to look at what interfaces the kernel is proposing and are they sufficient. And so today, all we have that's nearing completion is Lucas's CMA ABI, which is basically is going to export the entire SPDM transcript and the nonce that came with that, and so the user space could validate, so that like host user space could validate CMA. But that's the native CMA case, which is kind of interesting that we can reuse some of that, but like it's really not the full end-to-end that we need to do for TDISP. And my understanding is that like everybody I talk to has a different use case where they want to get to the measurements, and some people want it in user space, some people want it in their driver, some people want the Linux PCI core to do some stuff for them. And I think the kernel has to be open to being in all of the above and not preclude the use cases, especially because people different environments may want to, like, I think this is what the even it was an SPDM that has which standard talks about the different models, like a passport versus a
RATS model.
The RATS model. Yeah.
The RATS.
Because you could have a model where you just inject golden measurements into the kernel and the kernel just validates those things, but it doesn't really give a chance for endpoint drivers or user space software to get in and get their fingers in and do their own kind of things. And so I think what this is going to look like is a bunch is kind of following along with what's happening on CMA, is provide a way for all the device measurements and and a way to retrieve them with a nonce and have that interface be available certainly to user space and probably also to endpoint drivers to ask the PCI core to just do it again with this new nonce and transfer that stuff around. So that feels like similar to how we allow PCI config space to be accessed from user space and endpoint drivers, we should allow device measurements and things to be retrieved both from user space and endpoint drivers. Like the last thing I want is for the Linux PCI core to be a mid layer that you have to kind of be beholden to its whatever the mid layer mechanisms allow. It should be a library that allows any policy to be deployed by a leaf agent, where the leaf is either user space or the leaf is the endpoint driver itself.
Great.
So along those lines, this is my next step, and the reason why the list has been kind of quiet is I'm increasingly finding that just talking in theoretical terms is not useful, and we really don't have access to either a QEMU model or anything that we can. Everybody can fire it up and say this is working for, because not everybody has hardware, or the same hardware. And so DevSec test is kind of inspired by some similar things we do for CXL testing, which is we know all the interfaces that the kernel is going to call to enumerate these devices. Same way we know how all the interfaces the kernel calls to enumerate CXL resources. Just there's a lot of details behind the word just, but basically just inject fake responses for those calls, and so the kernel thinks it's discovered a TDISC capable device and thinks it's talking to a platform firmware or TSM vendor device, and just mock up all those interfaces. And so it's hopefully faster to do this than try to build QEMU models for it and try to get all that approved and accepted into QEMU. So it's kind of a quick and dirty, well, hopefully not too dirty, but a quick way to say, I want to test the connect flow, and I want to test a TSM vendor driver that returns a certain payload of interface report, or a certain payload for device certificates, and we can just mock up those payloads and get those kernel flows going, and then hopefully fill in with per vendor drivers later. But in the meantime, we have a test vehicle for it. So that's the thing I'm working on now, and hopefully we'll be able to share that soon.
Is this still the pre-bind model, Dan?
The pre-bind model. I'm hoping that this thing can support both models, like where we get the. I mean, I really think that the pre-bind model is already it's already not what we want to do, even in the medium term, just because it ignores error states.
Yeah.
Like, I'm not even that basically, like, that feels almost more like a science experiment than a solution, in the sense I think we're going to immediately want to get to the point where, like I'm not going to have confidence in the implementation if all it understands is pre-bind, because it's basically cutting out like basic architecture requirements. Yeah, I mean, yeah. So what this might end up being, though, is that you run DevSec tests on the host side. It pretends to connect devices, but you actually can't, like, do any traffic to it. Like that when you wanted to go do the test side, you basically have another module that's faking the guest response, and so depending on what side of the infrastructure you're testing, you might have to do two different environments. But yeah, my hope is that we can use this as a place for vendors to be like, okay, so instead of saying, well, TDX does this, well, SMPTIO does that, and ARM does this, we can just say, okay, what does DevSec test do and what is your delta to that vendor, and so we can have a kind of a common language for some of these things. Yeah, but other than that, yeah, I'm kind of awaiting vendor feedback and opens and for an upcoming call, really. But yeah, the beyond DevSec test, getting the KVM and VFIO pieces going is also next up on my agenda for posting new code out to Linux Cocoa. But like I said before, because we didn't have too many opens or agenda proposals coming in, that this could be a short call today.
I have a couple of questions for you, Dan, if there's nothing else to talk about.
Yeah, we can throw it open.
Sure.
Go ahead.
In the postpoint model where you assign the TDI in a lock state to a guest, can the guest trigger DMA from the TDI to shared memory?
Can the guest trigger like before it's like when it's unlocked?
Yeah. The TDI is unlock state. Assume that SPDM and ID are established, right? So TDI is in unlock state. Can this TDI do a DMA to a shared memory?
I would hope so.
The spec allows that, right? So I'm trying to make sure that
yeah. Like the shared mode should work. I think. I guess the question is, do we support dynamically switching the device from shared to private mode?
But in the postman model, when you assign the TDI in unlock state, the guest can trigger the bind, right? So it goes from unlock to lock to run. So which means that yes, if you're supporting post bind, that assumes that you're also supporting dynamic switch of TDI from shared to private mode, isn't that?
Correct. Yeah. I guess the concern I have is whether the whether we in QEMU, like whether we assign devices as private and basically build the private tables and have that ready, like have it ready to go, and but not have shared tables in the beginning, so that if you tried to access it in shared mode, nothing would work. Um, I feel like that's only a stopping point along the way, that we want it to be the case that the device can be bound after the fact and have all the page tables established to run in shared mode, and then optionally later go from lock to run. Or but for the post-buy model, I think you also need the, like, you need well, not you, but like the the solution needs DMA between the locked and run state. Like,
No,
so,
that is not allowed, right? So
yeah.
there's no DMA in lock state. So DMA is allowed in either an unlock state or run state.
Okay. Yep.
Yeah. All right. So as long as that's in roadmap, it's good.
Yeah.
So I have one more question. After you fetch the device interface report, will that be exposed to the device drivers? Will there be any calls to fetch in the interface report?
That should, like, to me, that's along the same lines as config cycle access, where either either user space or an endpoint driver can ask the PCI core for the interface report. Basically, I see no reason for that to be hidden or restricted to the PCI core.
It needs to be translated though, right? So when the device is asking, give us all the T and non-T ranges, it needs to be translated. So it's not the actual interface report that has the random offset included, right? So it needs to be translated.
That's true. But that could be a common helper that says,
yeah,
give me translated interface reports.
Correct. And given that the guest is expected to parse the device interface report, then it needs to have the knowledge of TDISP versioning, right? Or TDISP data structures. So how do you, if that is the case, how do you, yeah?
Is the TDISP specification at least good about making no backwards or forwards incompatible changes to these formats? Like, if we don't have the version, can
I have to look at the spec, but I think something to think about. And we're
something to think
talking
about.
about,
Okay.
3 entities that we're talking about: the device, the TSM, maybe host as well, and the guest. All needs to understand the TDISP data structures. So how do you come to the common denominator?
Yeah, this is actually another good reason to have a test a test module, a test framework that can inject version mismatches, because I feel like we're going to get like we'll pick a happy path that the DevSec test will initialize first, and then we'll probably immediately run into a bug with some like, hey, when I do this real thing on my real platform with my real device, we have this menu of version mismatch, and then we can backfill DevSec tests with, okay, like, let's make sure we don't do that again, and here's how we negotiate these versions. Yeah, I mean, in general, like, my instinct from device drivers is trying to never put a version check in anything, but I feel like TDISP and security protocols don't have that same discipline, or they don't have that same arrangement where doing version negotiation is expected. I mean, I'm hoping there's some like lowest common denominator that we can fall back to, and only have to support the newer versions when there's some kind of security reason to do so.
Yeah. I mean, one of these, if one of these entities must provide some sort of backwards compatibility or maybe forwards compatibility too.
Yeah.
We don't have to discuss the solutions here then, but something to add to the future agenda.
Okay. I took a note on that one. For negotiation. What was the note we wanted to take on the post bind model?
Yeah, two things, right? So one, we want to make sure that when the TDA is in unlock state, we can do our DMA. And of course the MSIX too, right? The interrupts.
But I feel like, I mean,
I think we should support that case, right? So my understanding is that if we if we do the connect verb and not do the bind verb, at least we need to make sure the device can work fine. For example, in native with device driving host, or for example, if we start a legacy VM with a device assignment, we should make sure that device works fine with connect only.
Yeah.
Right.
Yeah.
But like, it's right. I mean, every time, like, as I think about this, I'm trying. finding it hard to not support that in the sense that like I feel like we'd have to actively break something to like the base assumption is that legacy device assignment works, that the shared mode works, and the only reason that we're doing all this work is because shared mode is not performant, and so we're not going to break shared mode assignment on the way to private assignment.
Yeah.
Like, I mean, so maybe go. Was there a specific concern there that we would somehow break unlocked DMA, or is it the fact that you want to make sure that unlocked assignment is possible?
Yeah, I just want to make sure that is possible, Dan.
It- but do you want unlocked assignment with like IDE stuff? Like, I mean, I'm hoping that IDE established or not doesn't matter for the.
It doesn't matter, correct?
Okay,
It doesn't
okay,
matter. Yeah.
okay.
But if you're talking about error scenario where the TDI goes back to unlock state, IDE and SPRIM is already established.
Right. Okay. Okay.
Yeah.
So you're more concerned about like if we bounce out of full out of run state, can we issue DMA in shared state?
Correct.
Okay.
Yeah, both cases, right? Doing initial device assessment where you're assessing a device in shared state, can you do DMA? I think that is possible. And also doing error transition, when you go back to unlock state from run state, can you do the DMA?
That makes sense. Because also like the error recovery flow is going to be vendor device device driver specific.
Yeah, correct.
And if that device driver needs to do a DMA as part of it, we need to make sure that gets restored.
Yep.
So yeah, this kind of also goes back to what we're kind of expecting the host side, and like assuming a non-malicious host, like so a host that's trying to be helpful. What my expectation is that once you tell a PCI core that you want this device to be connected, that state is basically persistent until you tell the device to be disconnected. And what I mean by persistent is that if any other operation happens to that device, like if you connect and then you go and issue the reset command through PCI core sysfs to say, hey, reset the bus, that the PCI core is responsible for reestablishing the connection, to be like, hey, you were connected previously, you issued a reset that destroyed the connection. As part of that, I'm going to restore the connection for for you. And but like, yeah, but if somebody issues a reset directly to the registers without going through the kernel, then they get to keep the pieces scenario. So we're not going to do automatic error recovery, but we're going to do automatic restoring context if you through the interfaces, and that probably also makes sense because like when we do VFIO assignment, it tends to issue its own resets, and I don't want it to be the case that you that once you register the intent to connect to the device, that any other subsystem that also gets a hold of that device and thinks it can do a reset to it also doesn't need to worry about restoring connection. It just needs to ask the PCI core to do it, and it'll come back to it in the same state.
Yeah. Is SPDM, if you do a PFFLR, do you expect SPDM to be reset, or the spec doesn't expect that to be the case though?
I don't think the spec is, yeah, I think Connect would, I mean, so the spec doesn't require SPDM to be reestablished, but what I don't know is what granularity each vendor is going to allow for its connect verb. Like I know, like what we're kind of looking for on the TDX side is that inside of the Linux connect verb, there's going to be some daylight between SPDM and IDE setup. As far as I understand, for other technology, there might not be daylight, so that that if you reconnect, you might actually reconnect. You might actually redo. You might redo the session.
Which means that you have to do the SPDM teardown before you do that, right? Because device may not clear the SPDM states as a part of PFFLR.
Okay. Yeah. So that might end up being a corner case that is we kind of push out to vendor TSM drivers to be like, hey, you're being asked to reconnect after a PFFLR. If you do the minimum, if you can, if you just need to restore IDE, go ahead do that. But if you otherwise, yeah, if you need to redo everything, then you need to take care of SPDM session teardown and do that as well. But that might end up being a per vendor driver difference because we ended up with because TDIS stopped specifying at some level and vendors all went off in the different directions.
No, it does though, right? TDIS has a very clear.
Well, TDIS does. TDIS
yeah.
does, but in terms of like the interfaces to TDIS, like some people think, oh, like well, TDIS requires this. You know what? We're going to combine locked and run, or we're going to combine SPDM session establishment and IDE into one verb kind of thing. So from the Linux side, we can only do like the lowest common denominator, which is the connect verb. But yeah, each vendor might allow different levels of flexibility beneath that.
Sure.
But that's a good one. What was concerned about MSI interrupts? Just making sure that those flow for that the
Correct.
device can issue upstream rights.
Correct. Yeah.
Okay.
Yeah, during shared state. Yeah. And another point we noted is for the translator, the T and non-T ranges for the device drivers.
Yeah.
Some hyper APIs. Yeah.
So this one is a bit more aligned, or is because that's a bit more related to what the PCI core already does. Like we have different APIs for saying, hey, PCI core map this device, and for very simple PCI drivers, it just like maps all the bars. What I don't know, and where I want to start writing code is that how far does that kind of basic interface get us, where we just assume like, oh, every bar you can have access to should be like if you call the Linux core APIs, you can do it. You get everything mapped. But this kind of sub bar mapping of this, like it could be that fine grained, right? It could be a bar with a smattering of TE and non-TE ranges within that bar, right?
Yeah, I think the PCI core can do all the mappings right after it gets the interface report. I think that's fine.
It can do all the mappings. I guess. Does the device driver want to only map a subset of the interface? Like, does the device driver want to say, oh, hey, the interface report says map all these. I only care about a subset of that.
No, that's not the use case I'm talking about. I'm talking about a case where you do all the mappings, but just give me the ranges so I can manage my own heap. For example, if the device exposes some non-TE range in say bar 1 or bar 2, the device driver may want to manage that independently. It may want to expose the non-TE ranges to the user mode and have its own heap on top of it. So for that to work, it needs to understand what are the non-TE ranges addressed by the device.
And map those. Yeah, make sure we have shared mode MMIO mappings for those non-TE ranges.
Shared mode mappings for non-TE ranges.
Like so that the guest user space can within a bar have private mappings established and shared mappings established.
Correct. So to give an example, we use non-T. We can use non-T for RDMA use cases, right? So for the RDMA use cases, the device driver may want to expose non-T ranges to user mode and have his own heap on top of that.
When you say heap, you just mean a PCI
memory allocator,
bar
right?
mapping.
The device, yeah,
Okay.
the device driver will have his own memory allocator on top of it.
And this is also related to peer-to-peer as well, in the sense that you can have MMIO peer-to-peer mappings.
Correct. Yeah. I mean, so one typical use case for non-T memory is for peer-to-peer with a non-TDISC peer. So you can have a non-TDISC NIC fetch it from a TDISC device using bar 1.
Mm-hmm.
So I can take the non-T bar 1 off the device and have it mapped to the non-TDISC device. So for that to work, I need to understand. So we need to know what are the non-T ranges addressed by this particular device.
But the non-T ranges may not be cleanly delineated by bar. They may be within a bar, correct?
Yeah, it could be correct. Yeah. Certainly. So it depends on number of. I'm not sure there's more than one range supported in the device interface report, right?
Yep.
So maybe you can expose all the ranges and have the device driver make a call. It can pick all the non-T ranges.
Yeah. This feels like a scenario where we'll probably have a core helper that does the common path, but then just like you can manually call IO remap with different settings if your device driver knows what it wants to do. It just seems like the device, the core needs to provide that map to the device driver to either map it itself or just say, hey, Linux PCI core map according to the interface report and give me the mappings.
Yep, that sounds reasonable.
I think we had this in the past for other, like not shared versus private mode, but in terms of complex. Here is basically a sparse map of offsets and things, and give me this set of base virtual mappings for all of these ranges. That's happened for other drivers too. Okay, yeah, I took that. I took that note. But other than that, I'll do another call for opens or other topics when get recorded, and then talk about the next meeting.
Just one more question, Dan. Are there plans to support set MMA attribute?
Remind me what's needed there.
We can use that to toggle attribute of a page.
You mean like
from
to
T
make?
to non-T.
Oh,
yeah. Private to shared from shared to private.
Like within a, so with the interface report, which of the T non-T ranges are you talking about being able to convert a T range back
Correct.
to shared?
Yeah. Yep. Or the other way around, dynamically.
I know we does it need to be without tearing down the mapping? Because like I mean the Linux answer right now is for that interface is if you like don't establish an alias, but like basically if you need write through or something for an aperture, you need to unmap the UC mapping and then remap it with write through. is that a sufficient interface? Or are you talking about like, oh, hey, like take the existing virtual mapping and just change attributes in it without evacuating or tearing down or remapping?
Yeah, I think that's what I'm looking for.
Okay, that one might be a bit spicier. I'll have to give more thought there.
Sure.
Unless Howard Yulun has some thoughts there about that, I would say we'd take that off. But I captured it.
Sure.
And the reverse direction as well. Like, so going back to private again.
Yeah.
Okay.
Is there any real use case for that feature?
Yes.
Dynamically.
Yeah, there is specifically the remote RDMA use cases. However, I mean, if we don't do that, if you don't support dynamic conversion of T to non-T or non-T to T, then at boot time we have to, figure out the right non-TE size that we need to allocate. It becomes challenging.
Okay, so like the expectation here is, the interface report is probably going to be a coarse or a rough or an initial, like a best effort. What might be needed is probably going to be optimistic on how much can be TE mapped, and then at runtime you're like, oh no, that's too much. I need more shared space.
Correct.
Okay. But for RDMA, is this is like, but is this always peer to peer like RD, or is this like, is there like, because would this also be useful for like, you decided you need to have a shared device, another shared device DMA into the MMIO space of a TDI.
Yeah, that's typical RDMA use case.
Okay, so that's what you mean.
Yeah, that's what I meant. Yeah.
Okay. Our RDMA use case is really just MMIO peer to peer.
Yeah, correct.
Okay.
Yep.
Okay, yeah, that can be kept on the docket of things to work through. Okay, yeah, and any other opens or concerns?
I have few of the minor things. I know, for example, will there be an API to fetch the TDI error info? If TDI moves into error state, will there be a PCI API to fetch it, or do we need to have a device specific implementation to get it?
This is TDI error info. I mean, is this just a payload?
That's a TDS.
SPDM.
No, there's a, I think there's a TDS message.
Okay, but it's just an SPDM message that gets a payload back. That's the error,
Right.
kind of the error report.
Yep.
I'm assuming that's just that has to be there for the error recovery flow. The guest driver is probably going to need that for recovery.
Correct.
It was
Obviously, we know we rely on timeouts for detecting error, right? So there's no other secure way for communicating error scenarios. But after we detect the error, maybe we need to fetch the error log, error report from the device.
We do need to fetch the error log. I think we had, this wasn't, I think at the last call, we also went through the scenario of like we don't know when we can talk to the device again, that we might need to like the TSM needs to, like, we ask the TSM driver to do SPDM communications. When we go to an error state, that context may be in a state where the like if we PFFLR, then we can't send TDIS messages to that reference the TDI, because that TDI might be destroyed by the reset.
Right.
And so we might need some mechanism to reestablish the TDI so that we can tear down the context, like so we can tear down the old context. Like we might need to clean out, find a way to bring the context back up just enough so that we can tear it down again.
But if you do a PFFLR to bring it up, the old TDA state has gone, right? It's been wiped out.
The old TDI state is gone from the endpoint, but I think we still need to get that TDI state out of there might be a TSM firmware internal kind of context for that TDI that's been destroyed.
Okay.
But yeah, but basically, yeah, all that to say that the error info is probably useful to the driver to do his recovery flow. We need to make sure that can be, that there's an API for that.
Great.
Okay.
From driver point of view, so from my understanding is that so for each TDSP messages, so the response can be a TDSP error with some error code. So from driver point of view, so for example, if the driver issues a bind, because during the bind, we may need to do the log and get interface report and etc. So we need to expose on the TDSP error and also which message triggers that problem.
You're talking about in the case when a single verb needs to issue multiple messages. How do we report which one caused the error? Yeah, that's
Yeah, I see.
Yeah. It's a problem. Yeah, we need to figure out what we're going to do for reporting those, or like at some point, we're probably going to start with coarse error handling. Like if anything bad happens, we start over, and then we get more sophisticated over time, where we can actually recover from individual messages going wrong in different verbs. But to start, yeah, we might need to just hit the panic button and start over when some of these things happen. Okay. Actually, yeah. So I was worried we weren't gonna have a lot to talk about today, but it seems like we still did. So that's good. I still need to get still waiting for Lucas to publish his CMA and kind of transcript and nonce ABI. So we'll see how that goes. But I think he's getting closer. But yeah, that's the next step I'm waiting for on that ABI side. But in the meantime, I'm building this test module so we can check out different TDIS payloads and the PCI core interactions and get that all kind of plumbed out. Okay. Any last call for opens? Otherwise, our next get together is in that Europe friendly time zone or time frame in a couple weeks. And if not, have a good long weekend for those who celebrate on Monday, and otherwise we will see you next time. Okay, thanks everyone.
Thanks, Dan.
Thanks.
Thanks.
Thanks. Bye.
All right.